Hi there, in this video I'm going to show you how to create a vignette to write up your results in an R package. So basically coming back to our package here, we have our code. Is our R function KNN for nearest neighbors that we've written that calls our.c, and what we want to do is we want to run this on a bunch of different data sets and show the output in a report. And so the way that we do that inside an R package is called a vignette. And so there's a convenient way to get started with using a vignette by doing devtools : use vignette. And so you can see the syntax. First argument is the name. So the name of the vignette, maybe you can say report. I don't know. So it says setting active project, blah, 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 adding creating vignettes.report.rmd. So that's where we have to look in to write our report vignette. So let's take a look. We have in our package nearest neighbors demo, we now have a vignettes directory. And we now have this report.rmd file, which we're opening up here. And so this report.rmd file is pretty interesting file format. You've got some header that you should fill out with, like, report for project 1 on nearest neighbors. Put your names in the authors section. And then vignette index entry. I think you could probably just put the same title as you put here. And I think you can just leave these headers here, because I think what they're doing is they're specifying exactly how to render this. And so this is what we call R Markdown document. That's the RMD that you see here. And so there's a package called R Markdown, and there's a function called R Markdown that helps render these guys. And so essentially, you start out with this kind of skeleton, and so you should basically like delete all the stuff that's most of the stuff that's here, and and replace it with the contents of your own report. So basically, here what you see here is that, okay, first you have the header, then we have these like triple backticks blocks here, and so that denotes R code when you have the curly brace R that's starting it, and then you can give some options in your curly brace block here. This is the name of this code chunk. This code chunk here is called setup. That's what this says. And then include equals false. I think what that means is it's not going to show up in the final report that's produced. So this text outside of this block, it's just regular text that is going to be rendered. But inside here, this is our code that's going to be run. And since we have include equals false here, it's not going to show the code. It's just going to run that code. And so here you see another block of our code. Curly brace R, comma, fig show equals hold. And so basically this means that, basically you were going to show some figures here. Here they're just giving you some example of how to plot some data. And so because we didn't have include equals false, the default is include equals true, so we should actually see this code in the report. And so let's run it and see what it looks like. So if we click on knit here, I think that's what it does, and then he brings up this window which says report for project 1 on nearest neighbors. So we do the knocking. These are the values I filled in the header. And this is all the text that we have here. Notice that we did have our code chunk here, but it was not rendered. Going down here, we have some R code that is rendered in the document, and then you can see the results of executing that R code. So it puts those figures there side by side. It also renders tables quite nicely, and so you can use this. You're encouraged to use and adopt this template to write your report. So in particular, the other thing you can do is you don't always have to press the knit button to see the results. I mean, you can also just use Control Enter here, and that's going to execute that line of code, or another way to do it is you click this run button, and that's gonna run the selected line or the whole chunk or whatever. Right, so then you see the results in line. And another way to do it is you go to these buttons over here, run all chunks above or run the current chunk. So we run the current chunk, and then it gives us those two figures that are described therein. And it gives you a nice way of browsing through them there. Anyway, so what we're going to do is we're going to delete all of this stuff. And we're going to instead, we're going to create a new report based on this template that I provide. So what we want to do is we want to look at these data sets. So let's copy that. So I'm creating a new code chunk called data. And so what I'm going to do is I'm going to run my algorithm in all of these different data sets. And so, I mean, if we take a look at these data, let's take a look. I'm just going to delete all this text here. So, you know, one way to run it on all the data, I'm going to create a data list. I'm going to put all of these data sets in there. And, you know, one way to do that, I mean, we could just give the names of the different data sets, actually. That's probably the least repetitive way of doing it. Say heart. Don't know why it's always giving me that second quote over there. State. So how about I call this data name vec. So this is going to be a character vector of just the names. So then we executed that line of code, and we should have a console here somewhere where we can see what's going on. Where is our console? Here it is. And so we can see now we have all of those guys. So then we can create a data list as for data name in data name vec. What we can do is we can populate this data list based on those guys. Data name. No, that's what I want. Get data name. So get is a function that's going to look up the variable name and get the argument. So get whatever is there, and I think that we can do. There should be some arguments here to get, which I don't know why we don't have any help, but let's just pull it up. Because I mean, what we want to do is we get it inside of the element stat learn package. Envir equals as an environment. How about that? So that's probably where we can specify that, or well, actually, yeah, what we can do is we can say library lm_stat_learn. There we go. And then you can say get, we run data name package equals lm_stat_learn. That's going to load that data set. Then if we do get data name, that's going to populate that list. Let's see if that works. Data name, data set, data name not found. Right, so what does that mean? Well, we have to. I think you have to tell the data command the literal character strings are names. Blah, blah, blah. the environment where the data should be located. Let's say that's right. Well, list a character vector. Yeah, so that's what we have to do. We have to provide the list argument there. So let's say that list equals data name. Let's see if that works. Yeah, it works this time. So then populate that. Then we can see, okay, we've just loaded all of those guys in the list. Actually, that's not super informative. So instead, what we can do, all of these data sets, well, they're all kind of in different format. So what we're actually going to have to do, instead of making the data list like this, well, we have to kind of make it in a standard format so we can kind of process them in a standard way. So let's try to do that. How about instead of that, let's do data list, and we're going to do it every time in something different. So here, let's go back to the prompt. Come back to the prompt, we have lm_stat_learn spam to class. Let's just copy all this stuff again and just put it as a comment in our code here so we can use that as reference. How about that? How do we do that? Comment region, that should be under code, comment lines, Control-Shift-C, that's great. So then what we're going to do, output is last column spam, so then we can say, okay, our spam data is equal to, let's see, yeah, lm_stat_learn spam. So let's look at that. Where's the spam data set? So that's a data frame. So we have the last column spam, and then we have all of the other columns. So what we can do is we can say with, or no, we can say so what I'm going to do is I'm going to say all of these things are going to be label vec equals, the label. Then I'm going to say feature mat equals, let's say as matrix lm_stat_learn spam. And so that's going to create a matrix based on those data, but what we want is we want everything except for that last column. So that's going to be incall minus incall that says to select everything except for the last element there. And so what that's going to do is going to make a list where we have that spam data set in a standard format, and then we have with the SA heart data set, well, again, we have output as last column, but how about we do the zip train data set because it's a little bit more interesting, a little different format here. So then we have zip train equals list, label vec equals lm_stat_learn, zip train 1. So the first column of that zip train is going to be the label. Remember the prompt says ignore classes other than 0 and 1 because we're going to only do binary classification. So what we can do here is we can first say, okay, we have that label column, and let's say in 0, 1, then we say, let's call this is binary. This is going to be a vector of logicals that tells us whether we should select the data or not. So let me say is binary. So we're only concerned about the binary classification because that's what we implemented here. And then we do the same thing here. Feature mat equals lm stat learn zip train is binary -1. Okay, so then that's going to create this list of lists. Let's just execute that and see what happens. And so now we have this new data list. And the reason why this is interesting for the purposes of our report is now we can have kind of a standard format. Every data set is described as a element of this list here. And right, and so there's an element. It says that the first element is called spam. It's a list of 2 items. The first element of spam is called label vec. Second element is called feature map. And so this is kind of strange. So we see that, well, here in zip train, we have label vec, which is a numeric vector. That's good, of 0s and 1s. And feature mat is a numeric matrix, which is also good, because that's what we're going to give to our C++ code. But here, in my first implementation here, it says that here we have a factor with 2 levels, so that represents a categorical variable in R. And here we have a character matrix, which is also not really the way to do it, because we need a numeric matrix. So let's edit our code so we can get that in the right format. So here in label vec, well, what we want is this vector of 0s and 1s. So let's say if else lm_stat_learn spam equals spam, then 1, otherwise 0. So then that will give us a vector of 0s and 1s that we can plug into our nearest neighbor algorithm. Then also with this as matrix thing, well, what we can do is we can say, we can get rid of that parentheses, first select everything but that last column, and then use as matrix at the end. And so then that's going to convert it to a numeric matrix, because basically, because if we called matrix on that whole thing, even though most of the data is all numeric, except for that last column, spam, which is a factor, it's going to convert it to whatever is like, so here it converts everything to character, because one of the things is not a numeric. So if everything is, then it is going to use a numeric. So let's look at what the data list looks like now. Data list. There we go. And so now we have something that looks better for automatic processing with our C++ code. Here it's a list of 2 elements. First element is spam. Again, so the element of spam is this label vector with this many numeric entries. And then the second element is this feature matrix with this many rows and this many columns. Right, so same thing for zip train. We have label vec and feature mat. And so basically then we can write some code in one of these blocks that says for data name in names data list. Then we have data list. Let's call it one data set equals data list data name. And so if we do that, then we can run some code on all of our data sets, right? So here, the one data set variable, this gets the value of one of those elements of that list there. So then we can, basically run our nearest neighbors function on every one in a very standard way, so we don't have to have a lot of repetitive code. So how about it would be something like you're going to be doing nearest neighbors CV, and then give, one data set feature map, one data set feature label vec, etc. Right? So that's basically what you're encouraged to do. Run all of the data, run out your algorithm in a very standard way like that. But the other thing that I said that you have to do is you have to do cross validation. So for every data set, you have to kind of randomly divide it into train and test, right? So So what you actually have to do is you have to create some train test splits. So the way to do that is you have to create a vector of fold IDs like this, fold vec equals right. So it's going to be sample rep 1 to n folds, L equals n row 1 data set feature map. Right. So what that's going to do is it's going to generate. It's going to assign a random number from 1 to n folds to all of your data points. Say if we have 5 folds there, we get this fold vector. And I encourage you to use the set seed function, which makes this always the same fold numbers, right? So here we see fold vec looks like this. 4, 3, 4. We see it's different now than this first iteration that we did. So we see if we run it again, we're going to get the same response. Here we go. Let's see. What does it look like? Yeah, we get the same response as this time because we set the seed, and so it's pseudo-random numbers on the computer. Anyway, so then what we have to do is we have to, do these train test splits. So what you're going to do is you have to write another loop for test fold in 1 to n folds, and then what you do is you say is train. All the training data are which data, right? It's the ones which are not equal to the current fold. So that would be fold vec not equal to test fold, right? And so then what you're going to do is you're going to run your algorithm here just with respect to these training data, right? Not with respect to all of the data. And then, save that in some model fit object or whatever, call it fit or model or whatever you want to call it. And then what you're going to do is you're going to do fit predict on one data set feature map not is trained. So that's going to make a prediction on all of the test data. You're going to get something, here I'm calling predvec for a vector of predictions. Then, what you have to do is compute test error of predvec with respect to one data set label vec not is trained. So that's the test labels, right? So then you have to compute either the squared error for a regression problem or the 0-1 loss for a binary classification problem. Compute the test error, save that to some data structure, and then plot the results in the rest of the report. And then I would expect you to go down, create some headings like, here's our analysis of the spam data set. And here in this block, you can access all the stuff that you created in the last block. So in particular, you can go, I would expect that you create another list like results list or something like this. And for every, result here, for every test fold and data set, you're going to save something called, data name fold vec, or test fold. Save your results, and then access your results here. Results list, spam, whatever this is, however you choose to store your results, access that and plot it or show the table, whatever. So I'm not going to show you all the details. I'll let you how to figure that out. But the idea is that you're going to be able to, I encourage you to try to do something like this in the beginning of your file so you can very clearly treat all the data sets the exact same way. And then after that, create a bunch of headings where you analyze the results that you've stored earlier. And for each one of your project, each one of the data sets, spam, zip train, you're going to be showing, and also write some comments on the results. So that's how you can write a report in RMD in a vignette in your R package. So Thanks for listening, and see you next time.